There is an element on Earth that holds more energy than anything you have ever imagined. It is hidden in rocks, unnoticed, but inside its atoms lies a force capable of changing the world or destroying it. Scientists have spent decades trying to control it, yet even a tiny mistake can unleash unimaginable power. What is this mysterious metal? How can something so small contain energy that could outshine entire cities? By the end of this story, you will see why uranium is not just a metal, it is nature's most powerful secret, a hidden force that has shaped history, science, and the fate of humanity itself. Uranium is a metal, but not like the ones we see every day. It is dense, heavy, and naturally found in rocks all over the world. Its weight is so great that a small chunk feels surprisingly solid in your hand. Yet, what makes uranium truly remarkable is what lies inside its atoms. Each uranium atom contains a nucleus packed with protons and neutrons, holding an enormous amount of energy. Scientists discovered that if the nucleus of uranium is split, it can release a force powerful enough to reshape the world. This is called nuclear fission. But uranium is more than just energy. It has a story that stretches from the Earth's crust to the core of human history. From powering cities to creating some of the most destructive weapons ever made, uranium's influence is everywhere, even though it often goes unnoticed. Its power is hidden, waiting to be unlocked, and once you understand it, you begin to see why it is the most powerful element on Earth. To understand why uranium is so powerful, we need to look inside its atoms. Every atom has a center called a nucleus, made of protons and neutrons surrounded by tiny electrons. Uranium's nucleus is unusually large and heavy, packed with more particles than most other elements. Imagine a tiny ball so dense that it holds unimaginable energy inside. This hidden energy is what makes uranium extraordinary. When scientists split the nucleus of a uranium atom, a process called nuclear fission, it releases a massive burst of energy. To visualize this, think of a single grain of uranium producing as much energy as burning several tons of coal. That is why uranium is used to power cities. A small amount can generate electricity for thousands of homes. But there is more. Splitting uranium atoms also releases neutrons, which can hit other uranium atoms and cause them to split too. This creates a chain reaction, multiplying the energy release in a way that is almost unstoppable if not carefully controlled. This invisible force has changed the course of history from science laboratories to power plants. It is both dangerous and awe-inspiring. One tiny piece of uranium can hold energy beyond imagination, showing us that sometimes the most powerful forces in the universe are hidden in the smallest things. Uranium's story is not just about science, it is about history, discovery, and human curiosity. The element was first identified in the late 18th century by a German chemist named Martin Klaproth. At first, it seemed like just another metal, dull and gray, with no hint of the immense power it contained. People studied uranium for decades, unaware that its true potential was hidden in its atomic core. In the 20th century, everything changed. Scientists learned that splitting uranium atoms could release enormous energy. This discovery led to a scientific revolution, opening the door to nuclear energy and, tragically, nuclear weapons. Uranium became central to some of the most significant events in human history, shaping wars, politics, and technology. Despite its dangerous reputation, uranium also became a symbol of progress. Scientists found ways to harness its energy to produce electricity and explore the mysteries of the atom. From the laboratories of Europe to the power plants of today, uranium's journey shows how a simple rock can hold secrets that alter the fate of humanity. Its story is a reminder the greatest power can come from the smallest, most unassuming sources. Today, uranium is more than just a metal with a powerful nucleus, it is a tool that shapes our modern world. Its most common use is in nuclear power plants, where controlled nuclear fission produces electricity for millions of homes and businesses. A small amount of uranium can generate energy equivalent to burning thousands of tons of coal, making it one of the most efficient energy sources on Earth. But uranium's influence goes beyond electricity. In medicine, certain isotopes of uranium are used in radiation therapy to fight cancer, saving lives through carefully controlled doses. Scientists also use uranium in research to understand the mysteries of atoms, helping us develop new technologies. Yet, uranium's power comes with responsibility. Its energy can create life-saving benefits, but if misused, it can be dangerous. This dual nature makes it one of the most fascinating elements on the planet. From powering cities to advancing science, uranium continues to show that even a small piece of metal can have an enormous impact on our daily lives and the future of humanity. While uranium can power cities and save lives, it also holds a darker side. Its atoms are radioactive, which means they release energy in the form of invisible rays. These rays are dangerous to humans and the environment if uranium is not handled carefully. Long-term exposure can harm cells, damage deoxyribonucleic acid, and cause serious health problems. The biggest danger comes from uranium's potential to create nuclear weapons. In the wrong hands, this metal can release unimaginable destruction in seconds, reminding us of its enormous power. Even small mistakes during mining, storage, or transportation can be hazardous, which is why handling uranium requires extreme caution and strict safety measures. Yet, understanding these dangers has allowed humans to control its power safely in nuclear reactors. Uranium teaches an important lesson: nature's forces are awe-inspiring, but they demand respect. Its energy can create or destroy, heal or harm, depending entirely on how it is used. This delicate balance is what makes uranium one of the most powerful and most dangerous elements on Earth. Despite its dangers, humans have learned to control uranium's immense energy. In nuclear power plants, scientists carefully split uranium atoms in a controlled environment, releasing energy in a steady, safe way. This energy heats water, produces steam, and turns turbines to generate electricity for millions of people. The process is precise. Engineers monitor chain reactions to prevent accidents, ensuring that the power of uranium is used safely. This controlled energy is so efficient that even a tiny amount of uranium can keep a city running for months. Beyond electricity, scientists also study uranium to explore the mysteries of the atom. By understanding its behavior, they develop new technologies, from medical treatments to advanced materials. Uranium shows us that what once seemed uncontrollable can be harnessed with knowledge and care. It is a force of nature that, when respected, can bring enormous benefits to humanity. Did you know that uranium is older than the Earth itself? Some of it comes from exploding stars that existed billions of years ago. Its isotopes, like uranium-235, are extremely rare, making up less than 1% of all uranium on Earth. A single uranium pellet, no bigger than a fingertip, can produce as much energy as burning 1 ton of coal. Uranium is also found in space rocks and even in the ocean, hiding its power in places we rarely imagine. These hidden facts show that uranium is not just powerful, it is truly extraordinary. Uranium is more than just a metal, it is a hidden force of nature. From powering cities to advancing medicine, its energy shapes our world in ways most people never see. Yet, with such power comes responsibility. Its ability to create or destroy reminds us that science and nature are closely linked. By studying and harnessing uranium safely, humans have turned a dangerous element into one of the most valuable tools on Earth. It is a symbol of both caution and potential, showing that even the smallest pieces of matter can hold extraordinary power. Uranium proves that the universe's greatest forces often lie in the tiniest, most unexpected places.